Hi everyone. Our project is on development of an AR-based training tool for tensile testing using UTM. So this is my team consists of Sohan. He's a computer science student, and myself, Rohit. I'm a mechanical engineer. So universal testing machine is a single machine used to conduct almost 14 tests. Tensile, shear, compression, and puncture and tear are few of them. The purpose of this project is to build a training tool in AR to teach a new student how to use this machine for tensile tests alone. So you can see UTM has almost 20 to 30 fixtures, which a normal student can get confused which fixture he has to use for which test. So we thought it's better to make a AR based assistant so that he can rapidly test any sample and any test seamlessly. So usually students tend to skip procedure or interchange the order of the procedure due to the high permutation involved in the testing process and the complex manual which may mislead him. The greater value we offer to students use through our AR application is we are avoiding the time and the effort taken to understand a complex manual, and it gives a 3D experience and it's a hands-on training. So this way we can avoid error while testing and also accidents while testing. This project is also an alternate to manual, and it's an effective way to teach students immersively and interactively. So primary objectives of our application is to reduce time of training and increase the effectiveness of test. So to do that, we are planning to create an AR application to train students to conduct tensile testing using UTM machine. And here out of so many tests, we are only taking tensile testing as a pilot project, and later we are planning to expand it for 14 tests. To avoid a general procedure, this will enable students to avoid general procedure and human errors while testing by assisted AR system. So to make this project a reality, the tools we are going to use is an install machine available at CRN Lab at UBC, Unity application to create run the entire model, AR model, SolidWorks and Samsung S7 tablet and HoloLens in near future if time permits. So this is our proposed architecture. So we have various people inside this application that makes this industry 5.0 ready. So one is number of students who interact with the application and the instructor who constantly monitors and modifies the instructions using an PC, and it is connected with cloud, and in turn it's connected with various databases like Canvas, and it is also connected with a mini cloud and an AR application. So this is how the entire structure is going to work. So as a testing methodology, we are going to first select 3 students from computer science engineering, 4 students from mechanical engineering who have no experience on tensile testing. We will ask them to use the application. We will score our application on student experience, time taken for the entire training process, and the number of error he performed while doing this process, and variation in test results, and observer score. So we will also have an expert in the field. He will observe the entire process taken care by the student, and he will score the student. And finally we will have a knowledge test and simple 10 MCQs where he will tell if the application designed by us is useful or not. So our timeline is like within 10th of March we will create the initial prototype, and within 18th of March we will fix all the bugs, and within the 1st April we'll complete the entire project with all the readings. So workload is balancedly divided between member of CRN and HCI lab. So milestones which we are looking into is design of 3D models of parts of UTM machine first in a .obj file and export it into Unity and program it, and setting up an AR project in Unity that can track the real world parts with rotations, make some animated parts of training as proof of concept, final creation of the whole training with combination of training steps and tracking. So this is how our prototype of the machine looks. So we have the actual machine, and here is the assisted AR part, which tells the student to pick it, and it also guides if where to place it and how much it has to be rotated. So by this way, he can easily take this actual part and place it in a proper way without any error. Our team would like to experiment the outcome of AR-based training to unexperienced students. Thank you.